Okay, randomness. What does it take for a selection to be random? Well, first thing is, nobody can guess the outcome before it happens, okay? And the set of outcomes has to be equally likely. So in this example, I'll read the paragraph below to mess my statistics up. It says circle one of the following numbers. So usually what I do every semester, I write them down. 1, 2, 3, 4. How many people would pick 1? Raise your hand. One person. How many people would pick 2? Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I say 11. How many people would pick 3? I'll count myself on this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many people would pick 4? 1, 2. Alright, so if you look at it, it says which number did you pick? Did you pick 3? Usually, most people pick 3. About 20% pick either 2 or 4, so ours is a little bit different. Most people pick 2. So if it come down to it, and I had to use the class to randomly select a number, people are predisposed to a number, right? So it wouldn't necessarily be random because each of them don't have an equal likely chance to be chosen, right? There's only a 1 out of, let's see, 23 chance that 1 would actually get chosen, right? Okay. There's only a 9 out of 23 chance 3 would get chosen, only 2 out of 23 chance 4 would get chosen. 2 is most likely at 11 out of 23. Okay. So, psychologists have proposed reasons for this phenomenon, but it simply serves to show an example that if I ask you to choose something randomly, you can't do it yourself because you're not random, right? You're going to have to use a computing software to do it. So, if you wanted to choose random numbers, there's various programs that can do it for you on both the internet, or if you have Microsoft Excel, it works too. So you can use a random number generator on the internet. You can use Microsoft Excel. They're all both pretty easy. Most people use the internet because a lot of people are rated with Excel, but Excel's pretty easy too. So I'm going to use Excel to do this. Next part. Try to. Where's Excel at? There it is. So let's pull Excel up. Start with a blank spreadsheet. Excel said not today. Ask it later. Put it on the next guy. Okay. Alright. So I'm going to make it big enough to try to see. That works. Okay. So using Excel and the random between function, let's make this one bigger. Generate 10 numbers between 1 and 4 and list the results before. Okay, so I'm going to use the random between function. You've got to put an equal sign for it. There it is. Random between, wherever between 1 and 4. Hit enter, give you 2. Picks a number, right? So if I want 10 of them, I can just click and drag it down to 10. Picks 10 random numbers. Okay. Alright, so if I'm looking at this, where's my little, it's not going to let me do it in the reader, is it? Let's do it up here. It'll let me do it here. Okay. Of course, it's going to be difficult. On my laptop, it lets me write on here. It's not going to let me do it. So, what's the problem? Internet Explorer. See that? Copy. Internet Explorer is good for nothing except this. Paste and go. There it is. Internet Explorer gives you the right icon. There it is. Huh? Because I had to teach online when everybody decided to skip town for the COVID disaster. And I had to teach all my sections online. I had to figure out a way to do it right on the computer. So it was a royal pain. And I actually got really good at doing it with the mouse before I decided to wise up and order the pen from Amazon that's sitting on my desk at home. Okay, so, alright, so we used Excel, we generated this. Okay, if I want to, I can write a 1 here, 2 here, 3 here, 4 here. Oh, that's terrible.
Yeah.
Where's the side?
There you go.
Let's try this again. Make the size smaller. Not saying it's going to be great, that's better.
Really good.
2. My handwriting's rough already. You've seen it in class. 1, 2, 3, 4. Okay. So if we're looking at the frequency of 1, we can go through and count. It happened 1, 2 times, right? We're looking at the frequency of 2. It happened 1, 2, 3 times. Okay. If we're looking at the frequency of 4, 1, 2, 3 times.
No, that's not. That's not.
That's 3.
That's 3.
Oh, son of a gun. You're right. Okay. So this one happened 3 times. Means the other one had to happen how many times? 4.
2.
2. That's right. Keep straight. Okay. So if you look at percents, right? 2 out of 10 is what percent? 20%.
30.
30, 20,
So he
30.
came up with his numbers. Oh, okay.
Okay.
Excellent.
Now, if you do this again, you're going to wind up with different percents most of the time, right? Ideally, if you got 4 of them, right, and you do 10 drawings, approximately what percent of the time should you see each? Okay, you got 4 numbers, right, and you do 10 draws. Approximately what percent of the time should you see each? So I got 10 draws. If they were all equal,
25.
you would see each of them 25% of the time, right? Is it possible to see them all 25% of the time if you only draw 10? No, because you'd have to see each of them 2.5 times, right? So if I should expect to see each 2.5 times if it was actually random, this is actually pretty close, right? I got 2, 3, 2, 3. No. Doesn't have to be perfect like that. All right, let's do it with 100. So I'm going to take this here. I'm going to drag it down. Oop. Hey now. There's like a major glitch with this computer that bugs me. Okay, so it's done 100 of them, right? We're not going to go count through this. We're going to let the calculator do it for us. Okay, so I'm going to copy them to start with. So I'm going to copy. I'm going to paste them up here so they can see. Okay. The reason I'm going to do that, I'll edit undo. Okay. I'm just going to paste the values. The reason I do that is every time you update something, it updates the values. I don't know how to fix that. I had never figured it out in 3 years. But every time you do it, like what I just did, it updates the values. Okay. If you copy and paste it, it doesn't. Okay, with just the values. I don't want it updating the values every time I do something, so this is the original set we had. In order to see how many ones I have, you can use the count if function. Count if. Okay. Range and criteria. Okay. So I'm going to count if my range here, I'm going to do C 100 or 1 to 100. Okay. Throw me a comma up there. I'm going to count it if it's a 1. There's 29 ones. Okay. So I'm going to count the same thing. Let me copy it. Okay. I'm going to count this one. I want to do that though. Same area, but I'm going to count it if it's a 2. There's 24 of those. Okay. Count if C1 to C100 if it's a 3, and equals count if C1 to C100 if it's a 4. So we're still trying to, if I've got 100 values, I should see about each of them how many times? About 25?
25.
Yeah, right. So what I see here, you can do it over here. You get 1, 2, 3, 4. Frequency here is 29, 24, 18, 29. Okay. So, and you can translate those over to percents too. So that's 29%, 24%, 18%, 29%. Okay, easy enough. Right. So far it's looking like Excel's pretty close to being random, right? So I expect each of them about 25% of the time. They're pretty close to that 25% of the time. Now, do I want to force them to be 25% every time? No. Okay. Reason why? Okay. Let's say I pick 4 values. If I force each of them to be 25% of the time, and the first one I pick is 1, can I ever pick 1 again? No, because this 25% is already there, right? So the next 3 choices, I know is not going to be a 1. You're not supposed to know anything about the next choice. Does that make sense? If you know something about the next choice, it's not random. So you can't force it to be a percent. You can say it happens 25% of the time, or about 25% of the time, but it can't be forced to be 25% every time. If you force it to be, eventually you're going to run into a situation where if I pick this one to be 1, 3, 4, that last number has to be a 2. If I force it to be 25% of the time. So that last number is not random. That last number is chosen by what was previous, right? This one has some association with what was previous, and this one has an association with what was previous. That's not what you want. You can do this for 1,000 numbers too. I'm not going to do it. I think you kind of get the point. Okay. All right. So we're going to run some simulations by hand. The simulation mimics reality by doing random numbers to present or to represent the outcomes of real events. We'll call each time we obtain a simulated answer to a question a trial. Suppose, in our example, Lucky Charms is running an ad with Pokemon cards, specifically giving away 3 different cards randomly, 1 in each box you buy. The likelihood of getting a Charmander is 30%, Squirtle is 30%, and Bulbasaur is 40%. How many boxes of Lucky Charms do you expect to need to buy in order to collect all 3 Pokemon? Got to catch them all. So, what we're going to do here, okay, let's see, if I remember this correctly, yeah, set this one this way. So, what I'm going to do is we're going to go through trials, okay? So, I've got our random number generated here. This is a random number table. I generated this one with Excel. Back when I took statistics for the first time in like 11th grade, they had random number tables in the back of the textbook. I think they still might for this one. That's obviously not something we're going to use here. If I expect you to do something with random numbers, I'll give you the random number table associated with it. Okay. All right. The way that this is going to work. Too large. Okay. So the first thing I'm going to do, I'm going to give, okay, in a random number table, it can be set up 2 ways. It can go from 0 to 9, or it can go from 1 to 10. Okay, this one I decided to do 1 to 10. Okay, a lot of the times you'll see 0 to 9, but you're going to have 10 outcomes. Okay. If Charmander, I have 10 outcomes. This one's 1 to 10. I need to label Charmander with 3 numbers because it's 30% of the time. You see how that associates? If it's 30%, it needs to have 30% with 30% of the numbers. So I'm going to give Charmander the numbers 1, 2, and 3. Okay? Who's next? Squirtle. Yes, I played a little bit of Pokemon when I was younger. Was 30% of the time, so I'm going to give it 4, 5, 6. Bulbasaur. It needs to be 4 numbers because it happens 40% of the time. Okay. Easy enough? All right. So, what I'm going to do, I want to figure out how many times it takes in order to get all 3. Right? I want to collect all 3. So what I'm going to do, I'm going to go left to right, and then when I get to the end of this row, I'm going to jump down here and start with this row. Okay? So I'm going down this one, and then this one. Okay? But I'm going to stop when I get all 3. So, first thing I'm going to do, the very first one is a 9. Okay? So component outcome is a 9. So I'm going to put a 9 here. Okay? A 9 is a what? It's a Bulbasaur, so I'm going to put a B. Okay. Next one is a 7. 7 is also a Bulbasaur, so I'm going to put another B. So I've gotten 2 Bulbasaurs so far. Only collected 1 out of 3. Okay. Next one's a 5. Okay. Yep. So I've got a Squirtle. I got another 5. So another Squirtle. Okay. I got a 2. 2's a Charmander. I've collected all 3. So how many times did it take me? It took me 5 trials, right? I'm just gonna write that on the edge. Easy enough? So I stop here. So that means for my next trial, I'll start here at this 1. Okay. So next one, I've got a 1. Okay, a 1 is a Charmander. Okay, 6, Squirtle. A 3, another Charmander, right? 7, Bulbasaur, and I'm done, right? So this one only took 4 tries. Okay, so I'm going to start back with this 7 right here. 7 is going to be a Bulbasaur. Okay, 9 is going to be Bulbasaur. 5 here. Squirtle. Okay, 4 here. Another Squirtle. 3. Charmander. I'm done, right? Got all 3. This one took me 5 tries. Alright, so I'm going to start here with this next one. It's 9. Bulbasaur. 10. Bulbasaur. 2. Charmander. 9. Bulbasaur. Okay, another 9. Bulbasaur. Another 2. Charmander. 5, which is Squirtle, which we need. Okay, so this one took 1, 2, 3, 4, 5, 6, 7 times. Okay, we got 4 more. Okay, trust me, it's harder for me than it is for you. Number 9, which is Bulbasaur. Okay, 3, which is Charmander. 8, which is a Bulbasaur. 6, which is a Squirtle.
How about that?
I was supposed to be a Squirtle. So it only took 4 on that one. Okay. So let's look at this one. 7, 8, another Bulbasaur. 4, Squirtle. 1 Charmander. This one took 4, right? Down to the final 2. Okay. This is a 1, which is Charmander. This is a 10. Bulbasaur.
Hold on.
7. Which is Bulbasaur. 1, which is a Charmander. 9, which is a Bulbasaur. 7, which is also a Bulbasaur. 9, which is also a Bulbasaur. 8, which is a Bulbasaur. 9, 2, which is a Charmander. Two, which is a Charmander. Run out of space here. 6, which is a
Squirrel.
Squirtle. Well, maybe not. Let's write Squirtle here. I would say 6 right there too. This one happened 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times, right? Okay. Got one more. I don't think this one's long. Okay. So we ended on 6, so we start right here with 1, that's the C, 8, which is a B, 6, which is a square. Alright, so this one only took 3. Okay? So, we did 8 trials by hand, which took way too freaking long. If you've got a computer program, it does these like that, right? So, what we find though, is that first trial took us 5, 4, 5, 7, 4, 4, 11, and 3. Okay? If I want to know about how many I should expect to buy in order to get all 3, what if I just add them all up and divide by 8, find the average? Does that make sense? Okay, so I'm going to add up 5 plus 4 plus 5 plus 7 plus 4 plus 4 plus 11 plus 3. Okay, and I'm going to divide that by 8.
5.37.
537. If it's wrong, it's her fault.
5.30. Oh, sorry. It was 43 divided by 8. 40.
Told you it was her.
5.37.
5.37.
And
What is-
43.
43. Okay. There we go. So I should expect to buy about 5 boxes, right, of cereal. Maybe a little more, 5, 6 boxes, in order to catch all 3. Okay. Does that make sense? Okay. So if we do trials by hand, that's how it works. All of them are happy. Okay. So. All right. How to build a simulation. Okay. First thing we're going to do is identify the component to be repeated. So here we're buying boxes of cereal. All we did was repeat the buying process until we wound up with all 3, right? A lot cheaper to go out and do it with a simulation than to go out and buy all those boxes of cereal 8 times unless you really like cereal. Okay, so explain how you model your component's outcome, which is exactly what we did right here. So we got 1, 2, and 3 are Charmander, 4, 5, and 6 are Squirtle, 7, 8, 9, and 10 are Bulbasaur. Explain how you will combine the components to model the trial. In our case, we'll look at the numbers in the table going left to right, each indicating what Pokemon it represents until we continue and find all 3. Okay. State clearly what the response variable is. In our case, we want to find the number of boxes it takes to get all 3. Run several trials. In our case, we decided to run 8. Easy enough? All right. Another style example we could have, okay? So, in this example, straight from your textbook, 20% of cereal boxes contained a picture of Hope Solo, 30 of Danica Patrick, and the rest of Blake Griffin. Suppose you buy 5 boxes of cereal. Estimate the probability that you end up with a complete set of pictures using the 20 runs below. Okay, so here, I'm only buying 5 boxes, and I either get it or I don't get it. Does that make sense? So, I bought 5 boxes. Either I got all 5 or all 3, or I don't. Okay, here, we have to do the same thing. We have to outline what's what. So, start with the top. Hope Solo has 20%. This one goes from 1 to 10 as well, so I'm going to give her numbers 1 and 2. You don't have to give her numbers 1 and 2. You can give her numbers 5 and 8, 1 and 9, as long as she's got 2 numbers, right?
Right.
If I make you do this, I'm going to tell you which number goes with what, right? Because I don't want people always have that person that's really difficult. Like, I want this one to be 5 and then I have to go through. No, I'm going to tell you Hope is 1 and 2. I was that person when I was in school. So Danica is 30%, so we're going to go 3, 4, and 5. And then Blake is the rest of them. 6, 7, 8, 9, and 10. Okay, so we've outlined them. Now, all we've got to do, I'm Clemson fan, I'm using orange. Okay, so here I've got a Hope, right? Here I've got a Danica. Number 10 is a Blake. Okay, I've got all three. Doesn't matter what the last two are, right? So I'm going to put a check mark so I got all three. If you want to go through and label the other two as Blake and Blake, cool. Okay, whatever you want, whatever floats your boat. All right. Here, 9 is going to be a Blake, Danica, Blake, 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 Blake. Yep, Danica, Blake. But I don't wind up with all three, right? Didn't happen. Okay, so you can put yes, no if you'd rather do that, Y, N, however you want to do it. Okay, if your checks and X's start looking the same.
Danica,
So we get Danica,
Blake, and
oh,
Blake.
and Blake. So here I wind up with all of them, right? You can go label the last two, but either way you're still going to wind up with all three. Does that make sense?
Mhm.
Okay, so I wind up with Blake, Blake,
Danica,
Danica, Danica, Blake. Didn't happen. Right? So Blake, Blake, Hope, Blake, Hope. Still didn't happen. Right? Blake, 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 Hope. Didn't happen. Right? So Danica,
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 Blake,
Blake, Blake. Still didn't happen, right?
Danica,
Danica, Danica, Blake, Blake, Blake. Didn't happen. Okay. Blake,
Danica,
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 Hope.
Hope,
So we're good on this one. Blake, Danica, Blake,
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 Danica. Didn't happen. Okay. Blake,
Danica,
Danica, Blake, Danica, and Hope. This one worked. And what we do is we wind up going through all of them, right? And then we find the percent of time that we actually wound up with it.
Danica,
Here to write notebook today and actually have the answer here so I don't have to write all of these. Maybe. We are on. But there's a strong chance that I didn't. I sure didn't. That means we gotta get through all of them. Let's go real quick. Okay, number 4 was Danica, Blake,
Blake, Danica,
Danica.
Blake.
This one doesn't work. So here we've got Blake,
no,
Blake,
Danica, Blake.
or Danica, Blake, either way.
Is it a 5 or a 6?
A 6.
Oh yes, it is Blake.
It is Blake. We're good, right? Alright, so we got Danica, Blake, Blake, doesn't work. Okay. Blake, Danica, no, it doesn't work. So we've got Hope, Blake,
Hope,
Hope.
Hope.
No, that doesn't work. So we've got
Blake.
Blake,
Danica.
Danica, nope. We've got Hope,
Danica.
Danica,
Huh?
Blake, Blake. Oh, that one didn't work either. So we got Blake, Hope,
Hope,
Danica.
Danica,
Right?
work.
Yeah, we got that one work. We've got
Danica,
Danica, Blake,
don't work.
doesn't work. Okay. Got
Work.
5 is
Danica.
This
Danica.
work.
This one works.
Danica.
Good. Okay.
Yeah.
So how many checks we got? 1, 2, 3, 4,
7.
5. I got 6.
Hold on.
Did I count wrong?
1, 2,
1, 2,
3, 4, 5, 6. Just kidding. I don't know.
6 out of 20, right? So, if you take your calculator, I don't know why I exited out of mine. Take your calculator. We should expect to get all 3 if we buy 5 boxes 30% of the time, right? If we did everything correctly.
Turns out
So if I give you a test question with a layout like this and ask you what percent of the time I expect to get all three, you can go through, say yes, worked, no, didn't, and find my overall percentage, right? Okay. Easy enough. Okay. Same thing for this one up here. Right? If I ask you what percent of the time out of these 8 trials do I expect to, or how many do I expect to get, you can find it as well, right? So how many boxes should I expect to buy in order to find all the Pokemon? You should be able to average that up and tell me that as well. Okay. This one, our last example of the day, is a hard one to test on, but I do want to show it to you so you'll know how to use your calculator in case you do have to do random stuff on it, okay? So here it says, 57 students participate in the lottery system for a particularly desirable dorm room. A large triple with its own bathroom on the first floor. 20 of the participants were on the USCA baseball team. All 3 winners of baseball were baseball players. The other students cried foul. Could an all-team outcome reasonably expected to happen if everyone had a fair shot at the room? Okay. So, let's run 10 trials. We're going to use our TI-84. In order to run trials on your TI, first you're going to hit the math button, scroll right to the PRB, which stands for probability, and you're going to scroll down until you see random integer. Okay. So, clear this out. Math, PRB, and integer. Okay.
Where's the PRB?
So, I'll do it again. Math, scroll right, like 4 times.
It's okay, I'll look it up.
And then you got your random integer right there, okay? So you're going to want to choose a lower and an upper. So I remember what we used for this one.
PRB.
So for this one, our lower, our first student's going to be number 1. Our 57th student's going to be number 57. So I'm going to choose numbers from 1 to 57. What you got?
Mine is a little bit different thing.
Yeah, probably so. You just go random int parentheses.
Yeah.
Yeah. So it's another one of the things you just have to remember what to type in. So lower goes first, upper goes next. And then however many you want to choose, okay? I'm going to choose 3, okay? The reason we're choosing 3 here is because we're choosing 3 people for the room. Does that make sense?
Yeah.
Okay. Okay. So I'm going to paste that in, and it chooses 3 people from a room, okay?
157, 3, and that's it? Mm-hmm.
Yep. I don't know if y'all all have the same numbers that I have.
You gotta put in parentheses.
Does everybody have the same numbers I have? If you do, it's probably because this is the first time you've ever actually used your calculator to do random integers, so it's calculating on the same. If I clear this out and do it for the next class, it'll all be different, okay? If you want it to get back to original, you just have to reset your settings, and it'll do it the same way. But that doesn't really matter, because it doesn't really matter, okay? So there's how many baseball players we say? 20 participants, right? So I'm going to let 1 through 20 be baseball players. And 21 through 57 are just going to be regular students. Okay, fair enough?
Sure.
So if my first trial here, and I think we're going to run how many of them? Did I say? 3?
Yeah.
We're going to run at least 10.
Okay.
Yep. Okay, we're going to run 10 trials. My first trial here.
It is.
You don't mind, I can see it. Okay. My first trial, do I wind up with all 3 baseball players? No, because 54 is a regular student, 52 is a regular student, 9 is a baseball player. So, no, I don't wind up with 3 baseball players, right? Okay. If I do it again, cool part with your calculator, just hit enter. It'll do it again for you. Okay. So the second time I do it, I get regular student, regular student, regular student. So no, I don't get all 3 baseball players. Does that make sense?
Yeah.
Okay, let's do it again. Boom. 3, 20, and 57. So I get 2 baseball players and a regular student. So I get all 3 baseball players, no I don't. Okay. Do it again. I get baseball player, 2 regular students. All baseball player outcome does not happen. Do it again. I get 1, 13, and 22.
No.
That's 2 out of 3, but still no. Right? Okay, 57, 54, 7, 1. No. 2 out of 3 closed, but no cigar. 32, 49, 56. No. 16, 16, 7. Yes.
Yeah.
Okay. And 3, 42, and 1. No. One more time.
No.
No, right? So, I only wind up getting a room full of baseball players
Yeah.
1/10 of the time, right? So, is it reasonable to expect that everything was done randomly and it wound up being that way? Maybe not, right? That's a really small, it's a decently small chance it doesn't happen, right?
Right.
If you wanted to be more precise, the more trials you get, the closer to the percent you get. Does that make sense?
Yeah.
So if I did 100 trials and found that percent, that would be closer to the overall percent. We'll eventually get to talk about that overall percent in one of the upcoming chapters. But that's it for now. So you should be able to do the homework for that one.
Can you help me do it tomorrow?
Yeah. If you have any questions, let me know. If you have any questions about your test, let me know. Other than that, y'all have a good afternoon.